Hello, pre-calc students. Welcome to lesson 2.3. We're going to start off with a warm-up. So I'd actually like you to pause the video right away and evaluate each of these functions at the given value. So go ahead and do that and then come back when you're done. You can use your table on your calculator if you want to do it that way, or you can plug in the values. Okay, let's see how you did. So hopefully you've got all of these answers. We're going to refer back to this later in the lesson. Okay, so let's move on. We're also going to have a second little warm-up. In this section 2.3, we are dividing polynomials using long division and synthetic division. So we're going to start off with the long division. So I wanted to do a little review of the steps of long division with a numeric example. So go ahead and do this division, pause the video, and also name each part of the division. Let's see if you remember that vocabulary, and then come back when you're done. Okay, let's see how you did. So hopefully you've got 493. That's what we call the quotient, right? 5 is our divisor. Here's the tough one to remember. The number we're dividing into is called the dividend. And then, of course, this is the remainder. So the division algorithm, we can use that to write out our division in this manner. 2,467 is equal to 5, right? Our divisor times the quotient plus the remainder. In this section, you'll be asked to write your solutions using the division algorithm. So this is how it would be done. For polynomials, f of x, that's our dividend. D of x is the divisor. Q of x is the quotient, and R of x is the remainder. So let's go ahead and try this division together. Now this should be reviewed from Algebra 2, but we're going to go through it step by step. If you remember, you divide the first term into the first term. So x squared into 6x to the fourth is 6x squared. Then I distribute that 6x squared over all three terms. So I get 6x to the fourth plus 6x cubed minus 6x squared. And then I'm going to follow the steps like I would do numerically and subtract. And I like to circle my new signs when I change them. It's just my habit. So I remember that I've changed them. I remember what the new sign is because your work can get a little bit tricky with lots of signs going on there. So these terms drop out. We have negative x cubed minus 6x cubed. So that's negative 7x cubed. And then let's see, negative 1 plus 6 gives me a positive 5x squared. And then I bring down the next term. And I start the process all over again. So now I'm dividing the x squared into the negative 7x cubed, which gives me negative 7x. Distribute the negative 7x over all three terms. So I have negative 7x squared and plus 7x. Change my signs. Combine the terms, so these drop out. I have 12x squared. That's plus 2x. And bring down the minus 3. One more time, so we have 12. I'm sorry, we're dividing into 12, which would be 6. Or, oh my gosh, sorry, my eyes are, I'm seeing different things here. We're dividing 1 into 12, which is 12. Okay, 12x minus 12. Change the signs. These terms drop out. I'm left with negative 10x minus 1. Okay, so now using the division algorithm, here's how I can write out my answer. I'm not going to write this whole thing. Let's just call this f of x. Okay, so f of x is equal to my divisor, x squared plus x minus 1, times my quotient, 6x squared minus 7x plus 12, and then plus my remainder. So actually what I could do to make this look a little nicer is do minus 10x plus 1. Okay, so that's how we write out our answer using the division algorithm. Okay, so I would like you to try this one. Now, keep in mind, let me help you set this one up, because here, if you notice, we're missing a term. So it's always a good idea to put in a placeholder to keep your work organized. So I'm going to have an x cubed minus 2x squared, and then my placeholder is for the linear term, so I'm going to add in a 0x minus 9. So go ahead and do the division and then write out your answer using the division algorithm. Pause the video, come back when you're done. All right, let's see how you did. So hopefully you got this solution with remainder 0, which means that I can write out my answer just doing the divisor times the quotient, and there is no remainder. I'm not going to put a plus 0 there, so we just do divisor times quotient. Synthetic division. This is usually the more preferred method. And this is, I hope you find this kind of fun, because it is kind of fun. Okay, so if you remember, we divide by the 0 of the divisor. So since this is x plus 2, the 0 of this would be negative 2. We put it in a little half box, and then we list out all of our coefficients. And you really need to check here for placeholders, because long division, it's more of a optional thing. You're not going to go wrong because you still have the variables as a guide. It's more for just keeping it organized. Synthetic division, you really need the placeholders, because if you remember, we dropped the variables and we only use the coefficients. So if you're missing a placeholder, your columns are going to get messed up. So we have every term here, so we're okay. So I'm going to list out my coefficients. And then we start by bringing down the first number, and then we multiply. So it's opposite operations of long division. We're multiplying, and then we add. And then we multiply, and we add. And we multiply, and we add. So what are we left with? If we start with a cubic polynomial, remember we're always dividing by a linear factor, so that brings it down by 1 degree. So this quotient is a quadratic, so it's 5x squared minus 2x plus 3. Okay, so x plus 2 times this would equal our dividend. So for this one, if it's x minus 2, I'm going to divide by a positive 2. Again, I have all terms, so I can list out my coefficients, bring down the 1, multiply, oops, I said bring down the 1 and I wrote a 2. Multiply, add them up, multiply, add them up, multiply, and we're left with a negative 7. So again, this is a quadratic. It's x squared plus 3x minus 11. So that times our divisor, x minus 2, equals our dividend. Okay, on the next slide, there's 2 more examples. I'd like you to try both of these. Okay, pause the video and then come back when you're done. Okay, let's see how you did. So compare your solutions. Pause the video if you need to. And then what I'd like you to do when you're done checking is go back to that first warm-up. Here's where we're going to use it. Compare your solutions from the warm-up to the solutions we got from our divisions. So leaf through the pages, look at your solutions from the other problems, and compare them to those values you got when you did the evaluating in the first warm-up. Let's see if you can make a connection. Okay, hopefully you noticed that when you evaluated f of negative 3 for this function, you got 4 as an answer, right? In all these problems, the remainder was your solution from the warm-up. And that leads us to the remainder theorem. The remainder theorem says if f of x is divided by x minus k, then the remainder is f of k. And that's what you were doing in the warm-up. You were evaluating f of k. We did the division by f of, or x minus k, and you should have found that the remainder of that division is equal to f of k. So this leads into the factor theorem, which says that f of x has a factor, x minus k, if and only if f of k is equal to 0. So my divisions tell me 2 things. This tells me, first of all, that x plus 3 is not a factor, because that's what we'll be looking for in the future, is factors and zeros. I know it's not a factor because I didn't get remainder 0. It also gives me a coordinate that's on this graph. Right? When x is negative 3, y is 4. Excuse me. So in addition to knowing that negative 3 is not a 0, I know the y coordinate of the point with x equal to negative 3. For this one, I know that f of 2 is equal to 29. So let's use the remainder theorem, and when you see this instruction, it means do the division, okay, to evaluate f of negative 4. So you don't want to just take negative 4 and plug it in, right? You want to use the remainder theorem, so you want to use the division. So go ahead and try this, and let me warn you, you want to divide by negative 4. We don't change the sign here. When we're given the factor, like we were in these problems, then we divide by the 0 of this factor. But if you're asked to evaluate, then you divide by that number. So start with your negative 4 and go ahead and do the division, pause the video, and come back when you're done. Okay, hopefully you got negative 92. If you didn't, go back and check through your work. If you can't find your mistake, then ask me in class. Okay, for this problem, we're asked to show that x plus 3 is a factor of f of x, and then find the remaining factors. So I'm going to start off doing division by negative 3. Here, notice I'm missing my x squared term, so I need that placeholder. So I bring down the 1, multiply, add, multiply, add, multiply, and add. And I got remainder 0, which I'm expecting, right? If you're told to show that this is a factor, you should be getting remainder 0. And then what am I left with? This is the quadratic, x squared minus 3x minus 10. And I can factor that into x minus 5, x plus 2. So those are the remaining factors of that polynomial. So there's the 3 factors. This is what f of x equals. So go ahead and try this example. Pause the video, do the division, and then make sure you get remainder 0, and then factor your quotient. Come back when you're done. Okay, so hopefully you got these values. Here's my work. Okay, so again, I'm expecting that remainder 0, and I got it. And then I factor the quotient from there. Okay, this is our last example. And this is a good one, because look at what we're doing here. We are asked to use synthetic division to show that x equal to 2 minus root 5 is a solution. So this is going to be a little messy. I'm going to ask you to again pause the video and do this one on your own, but I want to give you some tips first. For something like this, because you'll also in the future have solutions that you're dividing by that are imaginary. So whenever it involves 2 terms, you always want to spread out your work. Because when you start distributing, you're going to have 2 terms. Right? When I bring down that 1 and then I multiply, I'm going to have a 2 minus root 5. So give yourself space for that so that you can line up everything and be organized. Now, I'm going to give you a second tip. If 2 minus root 5 is a solution of this polynomial and it has rational coefficients, the only way that can happen is if its conjugate is also a solution. So your second division, you want to divide by 2 plus root 5 and divide into the quotient of this division. Do not go back to the original. Your whole goal here is to do the 2 divisions and bring this down to a quotient that's linear in the end. So after the 2 divisions, you'll have that linear quotient. So go ahead and give it a try, pause the video, and come back when you're done. Okay, here we go. So I did the first division and I got remainder 0, which is good. That's what I'm expecting. Here's my work over here on this side to multiply 2 minus root 5 times 1 minus root 5. Okay, that gave me this product here. Then I divided by 2 plus root 5. This division was a lot easier, right? Because I'm just distributing the 1. The root 5s cancel out. I just have a 3. I distribute the 3. And again, I get remainder 0, which is good. That leaves me with this, which is that linear factor I was talking about, which is x plus 3. So we were asked to list the solutions. So here they are. 2 plus or minus root 5 and negative 3. So that concludes our lesson for section 2-3. I hope you enjoyed it and keep on practicing. I'll see you in class. Have a good day.